Hello and welcome to Math with Lou. Today we are going to be talking about percentages, so let's dive right on in. Alrighty, a percent is a ratio that compares a number to 100. I'm sure we've all heard percentages before. It's super common in our day-to-day lives, super important. A percent is, again, just comparing something to 100, a number compared to 100. This I thought was interesting. Percent, it literally means per 100. And we should know that a century is 100 years. So per cent per 100. Um, this is the symbol we use. It's a forward slash with a circle on the top and bottom of it. And we can use percentages to solve proportion problems, which is the example I have below right here. Percentages can be solved by using proportions. Anywho, here's the example I have below. This reads, in a classroom, 16 of the 24 students are female. What percent does that correspond to? Okay, so the first thing we have to take a look at in a problem like this is the ratio of female students to all of the students. And here we go, ratio of girls to total number of students. The next thing we have to look at is our percentage ratio. So we're trying to figure out what percent it is. So we're going to put an x there. And because percent is per 100, that x is going to be over 100. So because these are equivalent proportions, we can now set them equal to each other. So we can say that x over 100 is equal to the ratio of girls to students, 16 over 24. And now from here, we just go through our steps for solving for x. We cross multiply. We now have 24x equals 16 times 100, or 24x equals 1600. Now we divide both sides by 24, and we get x equals 67. So 67 out of 100 students are female, or 67% of students are female. One of the ratios in these proportions is always a comparison of two numbers. In our previous example, the ratio we were looking at was 16 to 24. In the previous example, these numbers are called the percentage, the 16, and the base, which the 24 is the base. So we could think of that as 16% of 24, or 16 of 24. The other ratio is called the rate and always has a denominator of 100. So in this example right here, we could say that this is the percent, this is the base, and this is the ratio right here. Personally, honestly, I would not recommend thinking of it like this. Interchanging the percentage with the number in the numerator, I think that can get confusing for a lot of students. I think this is a way more logical and cleaner way of looking at it. Percent is equals the part of the whole. 16 is the part, 24 of the whole. If we compare that ratio, that gives us the percentage. I think this just makes a lot more sense intuitively. Percent of change, or p%, tells us how much a quantity has increased or decreased compared to the original amount. So we could take a look at that over here with this equation. The percent of change is equal to the increase or decrease of amounts divided by the old amount. And I have an example here. Actually, I think I have two. Nope, just this one. But I have an example here of building on what we're talking about with the percent of change. So in this example, Ricky is at the store where there is an ad telling him that there is a $6.99 discount on a shirt that originally costs $19.99. How much is the discount as a percentage? So again, we take the decreased amounts divided by the old amounts, so the ratio of the two. We just solve this. 6.99 divided by 19.99 it's a very long number, so we just round to, I picked 4 decimals arbitrarily, but 0.3497. Now, because this is compared to 100, we always take this decimal number and we multiply it by 100, and this gives us the percentage. So 0.3497 times 100 equals 34.97. So we would say that this is a 34.97% decrease in price. Again, the $6.99 discount corresponds to the shirt being 34.97% off, or I guess we could just round it to 35%. Okay. We can also find the value of something after it increases or decreases in value by a certain percentage. So here are the two equations we need for if we need to find, again, the value of something after we take the percent change into consideration. So if we have an increase, you take the original value of something and you multiply it by 1 plus the percentage, and that gives us the new value. And if we have a decrease, very similarly, we take the original value and we multiply it by 1 minus the percent decrease, and that gives us that new value. And here we have an example going over both of these ideas. So in my first example, Steve makes $20 an hour at his job. Because he works so hard, Steve's boss is giving him a 5% raise. How much is Steve making per hour after his raise? So first thing we're going to take a look at is how much he was originally getting paid, $20 an hour. We're going to convert his percent raise into a decimal number that we can work with. So 5%, this is the same as 5 over 100, or 0.05. And now we're going to plug it into this equation we have over here. So he's making $20 times 1 plus 0.05. This comes out to 20 times 1.05, and that equals $21. So after Steve got his 5% raise, he is now making $21 an hour. And here we have an example with a decrease in price. And this is something very common. We're all going to see this in our lives, when you go shopping for clothes. Jenna goes shopping for clothes. Her favorite brand of jeans typically costs $39.99, but today they are on sale for 30% off. How much will Jenna pay for a pair of jeans after taking the discount into consideration? All right, so again, we're going to examine the original value here of $39.99. Now we have to figure out what the percent decrease is as a decimal. So it's 30%, which is 30 over 100, which comes out to about 3.33. And we take this and we subtract it from 1 and multiply it by our original value. So $39.99 times 1 minus 0.33 is the same thing as 39.99 times 0.67, which is $26.79. And we know this is a good answer because if something is marked off in price, it should be cheaper than the original value. But that's it for what I wanted to talk about in this video. Thank you for watching. As always, the notes will be in the description, and hope to see you next time. Take care.